In this video, we're going to get started with exploratory sequential analysis using TramineR. TramineR is an R package developed around 2008 for mining, describing, visualizing sequences of events or states. This package has been around for a long time, and it's used in all kinds of disciplines, especially in behavior and social sciences, to examine sequences. It has been applied to different data sets with different temporal granularity, ranging from by year or by all kinds of granularity, by year, by month, by week, by second, and so on. So I encourage you to take a look at their website if you're interested in learning more about how it can be applied in those different disciplines in empirical research. And for this specific video, I want to first point out there are many links I provide here. There are 3 links that can be useful because the video will provide a very condensed introduction to this package to get us started. But if you want to go deeper in certain directions, you can definitely make use of those links for yourself. And TramineR has been used for many things. It has been used to visualize sequences, has built-in functions that visualize sequences in different ways. It can also give you descriptive statistics about a particular sequence. Such as frequency, entropy, and other types of statistics that might be helpful for you in order to describe the nature of a particular sequence and compare different sequences among each other. It also provides you different kind of algorithms to compute the distance or similarities among sequences so that you can use that information for clustering. You can also conduct discrepancy analysis to study how sequences are connected with other kind of variables if you're interested in. But in this short module, we're going to focus more on the exploratory use of TramineR so that we know how to convert or how to basically explore a data set by looking at the sequences in the data set. So in order to get started with TramineR, the first thing you want to do if you haven't installed TramineR on your computer is to install the package. If you're new to R, in R, you can use something like this, which is a command. You put into your console to install a package. If you use R Studio, there's a dedicated menu that allows you to install packages. So I encourage you again, if this is something that's new to you, you can play with it and search for any additional support online. After you install this package, the next thing you do is to load TramineR to your runtime on your computer, which can be achieved by using library TramineR, and this will just load this library into the runtime. And the information you see here gives you the version of the TramineR you're running, and also provides you some additional information, such as the website of this TramineR package, which is, I would say, pretty regularly updated with new citations, with new information from the maintainers of this package. And also for this module, as I mentioned, we're going to use tidyverse, so we can also load tidyverse packages by running this command. And if you see, take a look at those 2 different lines, I would mention that the quotation marks do not matter. You can put quotation marks around the name of the package, or you can just ignore them. You don't need to put them all the time. So I just want to show it's pretty tolerant in this case in terms of whether you use quotation marks or not. So now we have loaded both packages or both libraries. And again, it gives you a bunch of information. And for this video, I just want to quickly talk about some basics about working with TramineR. The first thing I want to mention is in TramineR, because it is a package developed by scholars from particular fields, they may have different tastes or different opinions about how to describe things. In this case, in particular, they distinguish two different things. One is state, another is called event. And for them, or for TramineR, the state, which describes the status or, at a certain time point, how we can describe a person or a particular entity we're trying to describe. So here, for example, we use this example. It could be, for example, at the point of a course, right? At the point of the first hour, this person has been reading a book, right? So they use for example, the state of read to describe the status that person is in a particular moment. For example, this person can read for 1 hour, and then in the next hour, the person will write. And then in the next 30 minutes, the person would discuss. And in the next 15 minutes, this person will review. So the status describes, again, the status of that person at a particular time point or during a particular time span or time period, the status of that person. And for TramineR, they describe events, which is different from state, as whenever the state changes, it's an event. For example, when this person's go from reading the paper or reading a book to writing an essay, that's an event because there's a change of the state. The same applies, for example, when this person goes from writing to discussing, because every change of the state is an event. This might be not intuitive or counterintuitive for some of us, but I think I just want to point this out from the beginning. This is the way TramineR is thinking about state and events. I think it will be best if we can look at one example data set. And the good news is TramineR provides many different example data sets in the package. So it'll be very easy to just call the data from the package and then play with the data set to know about how it's organized. And in TramineR, there's a data set called actual. And the data set contains 2,000 different individual sequences of monthly activities, which, using our terminology, they're describing the states or statuses of those people from January to December 2000. And so in this case, this data set contains 4 different possible states, which include, they're using A, B, C, D to describe 4 different states. And A means having a full-time paid job, B means having a long paid, part-time paid job, and C means short part-time paid job, and D means unemployed. So as you can see, those 4 different statuses are pretty clear. It describes the status of the person at a particular time. And in this data set, if we want to take a deeper look at the data set, we can use this command to call out the data. If you want to, for example, know more about the data, before you do that, you can also use this help function, which starts with this question mark. And we give this data set also a bit more information, because the data set comes from the package. So after the question mark, I typed the package name, followed by 2 semicolons, and then followed by the name of the data set. And then so that you can get more information about data set from RStudio or from some other environment you're using, right? And after that, you load the data, and then to first get to know how the data looks like, I use this function called limbs, which is similar to the base R stir or structure. I don't know what stir mean actually, str. But glimpse is the similar function provided by tidyverse, which provides a little bit different information to provide you a bird's eye view of the data. So after I call this glimpse actual, you see this is output, which provides you a basic, some basic information about the data set. And you see there's an ID, house, age, education. I don't remember what those other variable means, but they're variables. This is probably status of civil status. And other type of variables included in this data set. And starting from this row, and that goes until the end of this data set, it's a list of states that have been captured by this data set, starting from January 2000 to December 2000. And you see for some individuals captured in this data set, there's some changes with their states or status during this 1 year time period. And that's what this sequential data objects is trying to capture, is to say, how are these people maybe changing their status, going from maybe part-time to a full-time job, or going from a full-time job to unemployed during this time, so that we can ask some questions about those individuals. So this is the data set. And then, using this data set, using TramineR, we can start to convert such a table, right? This is a table. Start to convert such a table into an object that can be leveraged by TramineR for different kind of things, including visualization, creating sequences, coming up with descriptive statistics, all the cool things we have been talking about. So the first thing we can do to achieve that goal is to call this function, which is called seqdef, which stands for definition or defined. So we're going to basically try to define a sequence object using the data we have. And here we want to use the columns from column 13 to 24, because that's the most important, because those columns capture the sequences in this data set. So it's a simple call, just to get us started. We put in the data and put in the columns that we care about, and then creates a specific sequence object called actual.seq. And then this is the outcome of, or output of this command, which provides you a very basic, description about the sequence object we just created. It tells you there are 4 different states in the data, A, B, C, D, and the state coding, because we didn't provide any labeling or long labeling, so it's the same as the alphabet. And it also tells that there are 2,000 different sequences, and the minimum and maximum length of those sequences, they're the same. They're 12. Just because this data is pretty clean, it's very well formatted, so there's less surprises, I would say, from this data set, right? So now we have this data set, the sequence object created. The next thing we can do is to plot some sequences. Again, this is very popular, a way to start exploring, because we're talking about exploratory sequence analysis. So we can take a look at some example sequences from a data set. So the function you use for that purpose is to call this seqi plot, and then provide the sequence object. Remember, this should not be the table, but the sequence object we just created. And we want the legends to be also shown, so that we have with legend to be true, so that we can see this legend to go with this figure or this plot as well. So after we call that, it will actually automatically pull up the first 10 sequences. That's why you're seeing only 10 instead of 2,000, because 2,000 will be a bit too busy for this graph. But to show you how this might look like, you see the first sequence has been the purple color all the way. So purple means B. That means part-time or long part-time jobs. So this person didn't change the status all through this time period. And then if we look at other sequences, for example, the second sequence, you'll notice that there are two different shifts, two different changes. Around this time, this person's changed from D, unemployed, to A, which is having a full-time job. And then near the end of November, this person changed from having a full-time job to unemployed. And the similar things can be applied to other kind of sequences. For example, for sequence 4, there's one change, or in the in TramineR's terminology, there's one event that occurred, which is about moving from C to D in this for this person. So this kind of plotting can provide you a basic, very basic overview to get to know the data and to know some sequences in the data. And if you want to know more about, if you want to also call out alphabet, alphabet, again, it describes those unique states in the data, right? Those unique status that's captured in the data. This information has been provided when you create this sequence object. But in case you want to also call that out, there's this particular function called alphabet that you can use to pull up the information about those alphabet or those states in the data set. So for now, I think for this video, it's about, again, getting started with creating sequential objects from a data format you have, and start to plot some sequences from the data set. In the next video, we're going to talk about different formats, different sequence data format that we will work with in different kind of situation, because in some cases, we are working with different data, and then the formats are quite different. So stay tuned.